Bismillah ar-Rahman ar-Rahim. In this video, we will see how the runtime complexity of a recursive algorithm is computed by using the back substitution method. As you know, the first step in computing the runtime complexity for a recursive algorithm is to establish or construct its recurrence relation. In this video, we will compute together the runtime complexity for a given recurrence relation, which is Tn equal n plus Tn minus 1, again by using back substitution method. Now the recurrence relation is given for a recursive algorithm. So this is the recurrence relation for a recursive algorithm. So when an input or when the argument is a value that greater than 1, this recurrence relation is applied. While when n equal 1 or less, okay, the runtime is equal constant, which is equal 1. Let us take example to understand this recurrence relation. Now assume that n equal 5. So what is the time required to run the recursive algorithm that its recurrence relation is given by this definition? Equal what? Equal n, which is 5 plus what? Plus t, or time required when the argument value is equal 4. What? Subtract 1. Now assume n equal 3. So the time required to run the recursive algorithm that this recurrence relation describe its runtime complexity equal what? Equal 3 plus time required to run the same algorithm when the argument is equal 2. Now but assume when n equal 1, so time required to run the algorithm when the argument is equal 1 is equal what? Is equal 1. Okay. Is equal what? Is equal 1. Now we take this one because the n equal 1, which is equal 1. Okay. So remember this. Now to find a runtime complexity in this for this recurrence relation, we need actually to use a formula. This is in front of me. Now assume we need to find the sum of the numbers from 1 to 10 equal what? This one. Instead of using calculator, you can apply this one. So how many figures or how many numbers in this series? 10. So n equal 10. Now we solve in a this one. N equal 10. So when apply this one, so sum equal what? Equal 10 multiplied by 10 plus 1 over 2, which is equal 10 multiplied by 11 over 2, which is equal 55. So sum for this one equal 50. Let us apply the same formula on B. So how many elements? 1, 2, 300. So n equal 100. So sum equal what? Equal 100 multiplied by 100 plus 1 over 2, which is equal 100 multiplied by 101 over 2, which is equal 50. So you can apply this one. So sum equal what? Sum equal n multiplied by n plus 1 over 2. N represent how many number in the series, and the difference between two subsequent terms is 1. So as you see, 1, 2, 3, 4, 5. We not apply this one when we need to find the sum 1, 3, 5, 7 for this. So we need, so when we solve this one, when we compute the runtime complexity, we will use this formula. So remember this formula. Okay, now remember this formula. Okay, let us start. Now, time required to run an algorithm equal n plus time required to run algorithm when the input equal n minus 1. Okay. Now, what is the time? Assume now, we need to find what is the time required to find what is the time required to to run the algorithm when the argument is equal n minus 1. Equal what? This one equal n minus 1 plus time required when the input size equal n minus 2. Okay. What is the time required when the input size equal n minus 2? This is equal n minus 2 plus time required when the input size equal n minus 3. Okay, so as you see, this similar to this, or this similar to this one. I want to change the color to show you how we need. Okay. And as you see, n minus 2 here, n minus 2, n minus 1, n minus 1, n, n. Next term, 2, add 1 to 2, 3. 1 here, 2. 0 here, 1. Now, I think you can guess the time required to run the algorithm when the input equal n minus k equal what? By analogy, n minus k plus what? Time required for n minus what? We need to increment 1, k plus 1, k plus 1. Okay. Now here we need to apply back substitution. Again, here we need to apply back substitution. Applying back substitution. Okay. Now we start with the first recurrence equation. T of n equal what? Equal n plus the time required when the input size equal n minus 1. Now we need to substitute this one by its value by this equation. So now time required equal what? Equal n plus what is, we need to substitute. What is the value of this one? This value. This is equal what? N minus 1 plus time required n minus 2. Okay, so we substitute by this one. Let me change the color. plus time n minus 1. N minus 1 equal n minus 1 plus the time required when the input size equal n minus 2. Now continue. Now time at t n equal n plus n minus 1 plus, now substitute by this one, tn minus 2 equal n minus 2 plus what? Plus what? Plus time required when the input size equal n minus 3. Go more. You need to reach up to, okay, t time required of n equal what? N plus n minus 1 plus n minus 2 plus, okay, until we reach to n minus k. So this is equal what? As you see, this is 2, this is 3, this is 1, this is 2. So now this is k. This should be what? Okay, I will make it in blue. Should be what? By analogy. Okay, should be what? This one. Should be n minus k plus time required when the input size equal n minus what? Here 3, here 2. K plus 1. And so on. So algorithm, will stop when the running or the execution of the algorithm, of the algorithm will stop when n equal 1. When the input size equal 1. Not n equal 1. Let us see when this equal 1. Okay, when this part equal 1. When this part equal actually 1. Again here, if you remember, now we said T1 equal 1. Okay, when this one, when this equal 1. So let us calculate when this equal 1, n minus k plus 1 should be equal 1. And n minus k minus 1 equal 1. And multiply this minus by k or minus by 1. Now keep the k here. Move all to the other side. I will need some spaces actually. So here equal n minus k, here n minus k minus 1 equal 1. This is equal what? Now minus k, keep it in the left side, equal 1, this one, minus n plus 1. So minus k equal what? Equal 2 minus n. Multiply by minus. So k equal what? equal minus 2 plus n. Rearrange the right side, so k equal what? Equal n minus 2. Okay. Now let us return to our recurrence equation. Now, time required when the input size equal n plus n minus 1 plus n minus 2 plus n minus k plus, this is equal 1, n minus k plus 1 plus t of 1. So t of n equal what? Again equal n plus n minus 1 plus n minus 2 plus, what is the value of k? N minus, what is the k? N minus 2. N minus 2. Okay, n minus 2 plus t of 1. So t of n equal what now? N again plus n minus 1 plus n minus 2 plus, you know, n minus n, this is n minus n plus 2, sorry, okay, n, this n minus n minus multiplied by minus plus 2 plus t of 1. Now time required equal what? Equal n plus n minus 1 plus n minus 2 plus n, cancel with n, plus 2. Now what's the t of 1? If you remember, t of 1 equal 1 plus 1. Sorry, I forget to write for you, plus, okay, sorry, plus n minus 2 plus dot plus. So here n minus 2, okay, plus dots plus 2 plus 1. Now assume n equal 10. So t of n equal what? T of 10 equal what? Equal 10 plus 9 plus 8 plus until we reach 2 plus 1. What this? This is series. So how we can solve this series? So this means what? So 2 of n equal what? Equal n, n plus 1 over 2. So t of n equal what? Equal n times n, n square. N plus n multiplied by 1, n over 2. So time here equal what? Equal n square over 2 plus n over 2. So this is the maximum. So this is big O of what? N square quadratic. Complexity. Okay. I hope this video will help you to compute runtime complexity for this recurrence relation. So you in next videos. Assalamu alaikum wa rahmatullahi wa barakatuh.